La 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 la. Alrighty, let's get ready. So this is 4.2 trigonometric functions of acute angles. Remember, acute angles is not just an angle that looks really cute, all right? It's an angle that is less than 90 degrees and more than 0 degrees. Yay, param pams. All right, let's get started. Well, what was 4.2? How do we begin this? Let's start by recalling some important information. Let me make sure I have the right size. I do. All right, right triangle trigonometry. This is the first time that we're going to be dealing with calculations and values. And these values are key to remember and understand for you to move on to more analytical part of trigonometric functions. And if you're interested in pursuing calculus, it's heavily used. So if you have a solid understanding, it will really, really help you out. All right. So let's begin. Let's recall that what similar figures are. And let's remember that they are just a scale of one another, all right? So if we multiply this by a factor, then whether it could be a whole number, then this figure gets smaller. If this is, let's say this is this type. If this is alpha, then this is alpha, and this is beta. If we multiply by a constant k, depending on the value of this constant k, the triangle is going to get either smaller or it's going to get bigger. And these are going to become k times alpha, and k times beta. This is what it is. So this is an example of similar figures. What are nested figures? Well, we can also have similar figures from nested figures is when we have a figure within another figure and they're still similar, and it is your job to take them apart. I'm sure you're familiar with this figure. You've seen it at some point. Well, really, there is a whole big triangle, and then they're saying that that triangle is similar to this little triangle. So then we have little triangle is similar to big triangle. And why are they similar? Because they both share the 90-degree angle and they both share this angle right here. Ta-da! So they're similar. And then this is another one. This is the one that I'm interested for you to actually understand. Does size matter when we're talking about a circle? And I'm talking more about the size of the radius because some students believe that a smaller circle the angle will be smaller than a bigger circle with a bigger radius, when in fact they're the same angle. What do I mean? Take this for example. We have the angle here. Can you see? Now just follow this one all the way to here, the little one, the first one. You see, we get this triangle. And then, well, that is similar to this one here, to this big triangle. All right. So we do have some similar figures in that as well. So does size matter? No, it does not if we're referring to the angle measurement. If you notice, this is the terminal side, this is the initial side, but it needs to rotate the same amount of degrees. So let's move on to the next part. Two right triangles are similar if one acute angle is equal. And that is because of this that we talk here. If they are similar and they're right triangles, by definition, right triangles means that one angle is 90 degrees. Well, that is this angle. And if that angle is 90 degrees, and because if they came from the nested part, we know that this angle is the same here and here. So we already have two angles that are similar, well, congruent, I'm sorry. Then that means that the third angle must also be congruent since we only have 180 degrees inside a triangle. So let's move on to the next part. What is standard position? It is key for you to understand the standard position of an angle. An acute angle theta is in standard position with one ray along the positive x-axis and the other extending into the first quadrant. So what does that mean? That means that I can only have, this is my first ray, and it's going to open this way up, it's going to rotate. This is an acute angle in standard position, or if I could have continued rotating, this is the other acute angle in standard position. So this is the type of measurements that we're going to be dealing with for now, because later on, once you understand these measurements that we're going to be getting here, if we're talking about the coordinate plane, then you can easily just reflect the values here. Now you have these ones, you can easily reflect the values here. Now you have it, and likewise over here. That is why we're beginning with this section on the 90 degrees or less. Let's move on. Yeah. Six trigonometric functions. I'm sorry, six trigonometric ratios. As I said, so if we grab an angle like that on the initial side along the x-axis, positive x-axis, and we just extend it around, we get this triangle. This is the triangle that we usually refer to when we're talking about trigonometric ratios and values. So when you say like, oh, sine of theta is equal to 3 over 5, or cosine of theta is equal to 7 over 9, that type of measurements, they're referring to this particular triangle measurement. All right, this is the angle theta, this is the initial side, this is how much it's rotating, and they usually are interested, if we're talking about a circle, something like this, they're usually interested in the x coordinate and the y coordinate. That is towards where we're moving with this unit. So let's see, here is my triangle that I said that we're talking about. And then what let's talk and everything. Every time that they give you a ratio, you're gonna have to look at what are they giving you right here. Everything is in relation to that angle theta. Granted, you can do the same calculations on this angle theta, and they will still be equivalent, but this is more like the standard notation that we've decided that we're going to use because it's the, in my opinion, and some other people, the easiest to understand graphically, visually for students. So let's talk about in relation to angle theta, that famous SOHCAHTOA that we have been learning since, I don't know, when did they introduce it? Seventh grade? In relation to theta, well, if this is a right triangle, this is always the hypotenuse. Hypotenuse. In Spanish, it's like hipotenusa. Interesting. And in relation to this one is the opposite, and this one is the adjacent. This is usually the order that I always find my sides. I always in a right triangle. I always first things first. I'm a realist. And second, I always look for the hypotenuse. And then after I know the hypotenuse, I go back to my angle theta. And for my angle theta, I look across and then I write opposite. And then by process of elimination, the last one is the adjacent. That is the way that I always see it in my brain. That is the logic that works with me. It might work with you. You might see another way. If you have another way, please do share it with us. That's one of the things that I really like about teaching, that I get to see, even though I teach it one way and like most students follow that way. There's the students here and there that do it a completely different way or like see it in a different way, and that is very interesting. So if you have a creative way that you follow these ones, it can only benefit us all. So drop the comment below and like, yeah, let's continue doing this. I can't believe you. I just asked you to drop a comment. That felt good though. Let's do. Definition of trigonometric functions. Trigonometric functions. Let's do this. This is a definition. More than the definition is what are we talking about? Remember that I said that we're going to be rotating this angle here around it, and every time that we rotate it at a different point along the circle, we're going to be getting a different triangle. These triangles have different measurements. All right, we can get as many, infinitely many triangles. Just start by rotating that angle. However, as mathematicians, we decided, that there's a particular set of triangles that we're really interested, and those are the ones that we're going to be working with, and those happen to be the ones that we deal with mostly in the unit circle. So we're heading that way. So get ready. Yeah, yeah, yeah. Lots of fun coming up, and we're not even done with the school year. Can you imagine what? Alrighty, let's continue. So what is this? Let theta be an acute angle, and a really pretty little angle. Acute angle. How many times have you heard that joke already before? I don't care. I will still use it every year. But anyway, theta is between 0 and 90 degrees. It cannot be equal to 0 and it cannot be equal to 90 degrees. I leave it up to you to explore this. What happens if theta is 0? What is the value of the next things? And what happens if theta is actually 90 degrees? What is the value of these ratios that we're about to explore? In the right triangle ABCD then. So they're referring to this triangle that we were, what happened that we were doing right here. Alrighty, so let's begin. This is how we define them, and I'm sure you're already used to this one. Sine, that is the name of the entire function. Sine, S-I-N-E, of theta. Not sine times theta, not sine parenthesis theta. We say sine theta. All right, we still say sine theta, but we write it for convenience with one letter less, as if that will make a huge difference, but apparently it does. So we will write sin and then parenthesis theta, and we call it sine theta. We don't call it sin theta. We're not a church. All right, it's sine theta. And what is sine theta? Opposite over hypotenuse. And then we move on to cosine, the cosine function. Cosine theta is equal to cosine theta. But you see, we don't have that additional part at the end. And again, it does not mean multiplication. And how do we define that? We're going to define that as adjacent over hypotenuse. And lastly, the last trigonometric function that we have right here is tangent of theta. And we're going to call that tangent theta. Alrighty, and what is tangent theta? Opposite over adjacent. So remember, no multiplication, no multiplication. All right, but what is sine of theta, Mr. Perez? What type of function are these or what? Well, remember, these are transcendental functions. Why? Because it transcends the four mathematical operations, but more specifically, these are trigonometric functions that refer to these many triangles that we can form inside this amazing circle of radius 1. So essentially, what is sine and cosine? These are just very nice values that we got at different measurements of angles, and we said, oh, this triangle has these properties, this triangle has these properties, this triangle has these properties. Let's call all these numbers in this triangle, let's call all the hypotenuses. Hypothenize. I don't know. That's a good question. I feel embarrassed that I don't know it. But anyway, let's call all the bases of the triangle. Let's call those cosines. And like, all right, so for all these triangles, all the bases where all the base values as we start rotating that ray on the first quadrant, all the x values that are going to be forming that triangle on the base, let's call them cosine. And then, well, all the height of all these triangles that we're forming as we're rotating that ray around, let's call those values the sine. All right, and then it starts getting more interesting with what is tangent and other stuff, and we're going to be exploring this. So we have these three, and every of these functions has a reciprocal. All right, what is the reciprocal of sine of theta? Well, it is cosecant of theta, and we're just going to abbreviate this as CSC theta, and this is equal. Well, what is the reciprocal? The reciprocal, you just flip your fraction, right? So this becomes equal to hypotenuse over opposite. That is the first one, and this is just a reciprocal function, not to be confused with the inverse function that we're going to be studying later. For right now, cosecant is the reciprocal function. And then, what is the reciprocal function of cosine? Well, that is secant theta, and we abbreviate this as SEC and theta, and we still say secant theta. And if it's the reciprocal of adjacent over hypotenuse, then it becomes hypotenuse over adjacent. And lastly, this is the easiest one to remember, at least for me. What is the reciprocal of tangent? Well, cotangent theta. And we just say cotangent theta. And this is equal to reciprocal again, adjacent over opposite. These ones, I'm sorry, you need to learn them all. You need to know what the ratio. Ooh, that's a bad choice of color, but we can always fix that. Let's fix it to another one. Yellow. They call me mellow yellow. Here we go. Blue and yellow make green. Look at that. Double learning today. You need to learn these reciprocal ones as well, please. It's going to be essential. Ooh, that's a fancy word. Essential. Essential. Don't be essential. We are essential. We are essential. Don't be suspicious. So here again, let me emphasize that one more time. It does not mean multiplication. So quick trivia question for you. How do we pronounce this right here? How do we say this? Ta 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 ta. What is that? We say f of x is equal to sine theta. And remember, what is theta? Or what is even sine? Well, remember I said that we have our triangle, and every time that we rotate this ray around, we're going to be forming this first triangle. If we keep rotating it, we form this triangle. If we keep rotating it, we form this triangle. Each triangle, to get to these corners along the circle, each triangle had to, have a base and has to have a height. So this is x comma y. Now this triangle here, well, it has this base x and it has this height y. So this is the coordinate of this one. And then same thing, this is the x and the y. So if we keep rotating, imagine how many little triangles can we form here? Infinitely many. We're not really interested in all of them. Can we calculate all of them? Of course we can. We are mathematicians and so are you. But we're not interested in that. We're only interested in key angles. On those angles are 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. If you can fully understand those measurements, you're all set for the unit circle. All right. So what is this function? This is a function of theta, and this is a function of x. This x value here can be measured in degrees or radians. Remember degrees and radians, that's what the previous unit lesson was really important, and all of them are important. So let's do an example and let's cut the video here, and then this was more like the explanation of what they are. Oh, by the way, and then we said, oh, all these x values, oh no, we're gonna get a set of coordinate values here, right? It's gonna be like x comma y, x comma y, x comma y, x comma y, for like the 0 degrees, for the 30 degrees, for the 45 degrees, for the 60 degrees, for the 90 degrees. And then we say, hey, all these x values, let's just call them cosines. All right, cosine of whatever angle. And all these y values, let's just call them sine of whatever that angle was. So each of these x, y coordinate values translates into a trigonometric value for cosine of theta and sine of theta. So when we're asking you for what is cosine of 45 degrees, what is sine of 30 degrees, well, we're referring to this. If you had an angle, if you rotated 30 degrees, you have this triangle. I'm asking you for, in relation to this point right here, here's my angle theta, in relation to this point right here, it has an x and a y coordinate plane, point, right? So, and we say that x is going to be cosine and y's are going to be sines. So if I'm asking you what is sine of 30 degrees, well, I'm asking you for the y coordinate of this particular point that is obtained by rotating 30 degrees. What is the value of that particular point? The y value? The y value happens to be what? You tell me. That is what we're going to be exploring. All right, so let's move on. Yay, 17 minutes. Oh my goodness. And I think I'm not going to edit this video at all. This is going to be raw, 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 mom. See you in the next video. Like it, subscribe. It's getting really tiring to copy the link every time, so it's just better if you just get the notification. I will still tell you on Google Classroom, but I would also appreciate the subscribers. I'm trying to make this big, not only for you guys, but for anybody. Remember, not everybody has access to not everybody understands material different, and I try to do my best to explain it as best as I can. So if I'm helping you out or if you seem to understand it, maybe there's another of your peers, not only in our school or like in any other school. Just share it. I know you might be kind of like, ew, I'm gonna be sharing a math video, but don't think of yourself. Think of Mr. Perez and think of other students that might need that help and that clarification. Or just imagine any person in random. Have you ever been on YouTube and just randomly a math video comes along and you're like, oh, that's interesting. That's an interesting topic. That could be any viewer in the world. It's crazy on my analytics, the people that I have and from where are they watching. It's interesting. But yeah, so watch the next video, 19 minutes. Oh my goodness. Every minute counts. Let's do this. Bye. Have a good one.